What's up guys, and welcome to this video tutorial. We are going over question 8 of the IEB AP Maths exam. This question has to do with absolute value graphs as well as a little bit of integration, not really integration but more integration theory. Okay, so let's get straight into the question. So consider the functions f of x, and we've been given f of x is equal to the absolute value of x plus a plus b, and g of x, which is equal to minus the absolute value of x plus 2 plus 1, drawn on a scaled set of axes. Okay, then we've been given the graph, and let's get into it. So question 8.1a says determine the values of a and b. Okay, so there's no real way for us to get the values analytically, so we are resorted to looking at the graph itself and getting the coordinates of the turning point or the salient point, which is minus 3 on the x and minus 4 on the y. Okay, with the salient point, it's easy to determine the equation of the graph. F of x is equal to the absolute value of x, and remember we always use the opposite sign, so plus 3 and minus 4. Okay, so that means that the value of a is equal to positive 3 and the value of b is equal to minus 4. Okay, then we can move on to b. Hence, or otherwise, solve for x is in, okay, this. So you guys might be uncertain how to go about this, but let's start off by just rewriting what we asked to find. Okay, x plus 3 plus x plus 2 greater than or equal to 5. Okay, now I have two graphs given to me, right? F of x and g of x. So basically what I want to do is try and figure out a way to pull out f of x and g of x from this, right? So what I'm going to say that x plus 3 absolute valued is equal to, take the x minus 2 to the other side, so minus x plus 2 absolute valued plus 5, and that shouldn't be an equal sign but less than or equal to. Okay, so now I've got this part of g of x, okay, but I need a plus 4, a plus 1, and I have a plus 5. So I'm going to take 4 to the left hand side, so x plus 3 absolute valued minus 4 is less than or equal to the minus absolute value of x plus 2 plus 1. Okay, and I've actually managed to get f of x on the right hand side. So basically what I'm looking for is where f of x is less than or equal to g of x. Okay, so let g of x be in green, so that is that graph right there. Okay, and f of x, let's go for red. Let's make it a bit thicker. Okay, so f of x is in red. Okay, so we want where f of x is less than or equal to g of x. Okay, and where we're looking for this region right here. This is the intercept, and this is the intercept, and we're looking at f of x is less, so this part of the graph right here. So it's all the way from minus 5, or from 0 to minus 5. Okay, and it is including those points. So what we're looking for is, therefore, it's between minus 5 and 0. Okay, so between that is where we solve for x. Okay, so next we move on. So given the graph y equals f of x in the diagram below, draw on your set of axes in your booklet y equals the absolute value of f of x. Okay, so that is basically telling us to mirror across the y-axis. Okay, so basically I'm going to mirror this. So let's say this is what the graph looked like. Okay, and what I'm going to do is I'm going to mirror it something like that. Okay, so basically I'm mirroring, oh that's not right, sorry, it's going to look something like that. So I'm mirroring it across that axis, the y-axis. Okay, and the reason for that is because we're basically, wherever it's a negative x, we're just inputting the value of x in. So we're going to get the this graph that we have now. Okay, so this is what what's in red would be your answer. Okay, then we move on to the next question. 8.3, we have a nice graph that's been given, and then it says that the integral from 0 to 2 of f of x is equal to minus 38.7, and the integral from 2 to 6 of f of x is equal to 74.7. Okay, so basically what does this integral tell us? It's telling us the area under the graph, or in this case above the graph. So the area here that's represented from 0 to 2 is going to be my blue area, and then from 2 onwards to 6 is going to be my red area. Okay, so question 8.3a says what is the integral from 0 to 6? Okay, remember integrals, we can add them, so we can say this is equal to the integral from 0 to 2 of f of x dx plus the integral from 2 to 6 of f of x dx. Okay, and therefore we can say that that's equal to minus 38.7 plus 74.7. Let's just write that out nicer. We can say the integral from 0 to 6 f of x dx is equal to minus 38.7 plus 74.7, which equals 36. Okay, so that is that, and then the next one is the absolute value. Okay, so basically what we're going to do is we're going to say the exact same thing, except this time it is absolute value, so we're going to take the positive of all of these. Okay, so it's exactly the same process. We're taking the positive values now, so it's 38.7 plus 74.7, and that equals 113.4. Okay, and that gives us 20 marks for that question. Yeah, so nice, nice question, not too much thinking. Maybe this question, let me go through the thinking behind it. Basically, I've been given this graph, so the easiest way to figure out this inequality is to try and pull out the f of x and g of x graphs from here, which is what I did there. And then using the graphs, I can then see where f of x is less than g of x, which was in the gray shaded area. Yeah, so thanks for watching, guys. I hope you found this useful.